So the first one we have there is the sum of the first n term of a series is 3n squared plus n. Find the nth term of the series and show that the series is an arithmetic progression. States the value of the first term and the common difference. The sum of the first n term is called Sn. That is what we use to denote sum. And what does it mean? It means you are adding the first term plus the second term plus the third term till you get to the nth term. So in reality, we are told to find S4. S4 basically means first term plus second term plus third term plus fourth term. That is what this means basically. So do you understand sum? So this T means term, S means sum. So if you look at this very well, the sum of the nth term, Sn, is given, the first term plus the second term plus the third term till you get to Tn minus 2, Tn minus 1 plus Tn. That is what you have. So this is just a formula of the sum of the first n term, and I'm getting to a point by showing you all this. Now this is Sn. So the sum of the term from 1 to n minus 1, this one will be Sn minus 1 then plus Tn. Do you understand? All these ones from T1, T2, T3 to Tn minus 1. This is the sum of the first n minus 1 term. So that is why I have written xn minus 1. So if I make Tn the subject of formula, Tn will obviously become Sn minus Sn minus 1. So this is the formula I'm going to look at the question. The sum of the first n term of series is 3n squared plus n. Find the nth term. So that is why I have to find this. I'm looking for the nth term. So what is the sum formula? The sum of the first n term of a series is 3n squared plus n. So Sn in reality is actually 3n squared plus n. So after that, what will be Sn minus 1? Basically, what Sn minus 1 just means is that anywhere you see n, put n minus 1. So Sn is 3n squared plus n. So anywhere you see n, change it to n minus 1. So this will become 3 open bracket n minus 1 all square plus n minus 1. So you have to expand what you have there. When you expand, you have n square minus 2n plus 1. Then I have plus n minus 1. By the time you open the brackets there, you have 3n squared minus 6n plus 3. That's what we have. Then plus n minus 1. So this will become 3n squared minus 6n plus n will give me minus 5n. 3 minus 1 will give me 2. That is what I'm going to have. So that at the end of the day, the nth term I'm told to find, which is equal to xn minus Sn minus 1 will be equal to Sn is 3n squared plus n. So put it there, 3n squared plus n minus Sn minus 1 is 3n squared minus 5n plus 2. So that at the end of the day, we have 3n squared plus n minus 3n squared. By the time you open the brackets, the minus will multiply the bracket. Minus 3n squared. Minus times minus will give me plus 5n minus 2. So please take note of that. Whenever you are opening the bracket, you have to be sure that you are not making a simple error, minus. So if you don't if you don't open the bracket with minus, you are wrong. So that's what I have. So that at the end of the day, 3n squared minus 3n squared, the answer will give me 0. N plus 5n will give me 6n minus 2. So let me rub off this side. So at the end of the day, the Tn will be equal to 6n minus 2. I'm done with this part. Now show that the series is an arithmetic progression and states the value of the first term and the common difference. So you can actually look at what you will do to show that the series is an arithmetic progression. First of all, find some of the terms. So we'll look for the first term. First term is T1. T1. Anywhere you see n, put 1. 6 times 1 minus 2. 6 minus 2 will give me 4. Then T2. T2 will give me 6 times 2 minus 2. 6 times 2 is 12. 12 minus 2 gives 10. Then T3. 6 times 3 minus 2. 6 times 3 is 18. 18 minus 2 will give me 16. Can you see that? So if you look at this, 4, 10, 16. Number 1 is it is increasing with a number. The number is 6. Or look at what you are to do. Find the common difference. You show that the common difference are the same. D is equal to T2 minus T1, and it's also equal to T3 minus T2. So this is equal to 10 minus 4, and it's also equal to 16 minus 10. The answer is 6. So it's an AP. Or when you got this 4, you could as well say this is 4 plus 1 minus 1 times 0 times 6, because that is how to write the n term of an AP, and AP is given as a plus n minus 1d. So the first term T1, see the second term, you can say this is 4 plus 2 minus 1 times 6. You can say 4 plus 3 minus 1 times 6, and if you actually calculate all this, you will get the same answer. So the sequence is an AP, or the series is an arithmetic progression. It's therefore the series is an arithmetic progression. With first term, since you are told to find first term, with first term A to be equal to 4, we have already looked for that. A is 4 and the common difference is 6, and common difference D to be equal to 6, and we are done with that question. Let's move to the next question. So in this question, they say in a geometric progression, the sum of the first two terms is 3, and the sum of the second and third term is minus 6. Find the first term and the common ratio. So now, of course, you know that the n term of a GP is ARn minus 1. So in a geometric progression, the sum of the first two terms, that means T1 plus T2, that is the sum. Sum means addition plus. The sum of the first two terms is 3. So the first term is A plus, now T2, if you put 2 here, you have AR2 minus 1. That is AR raised to power 1. 2 minus 1 is 1. So it's equal to 3. Let's call that equation 1, because you are actually going to arrive at a simultaneous equation, and you will have to solve for both the first term and the common ratio. Now again, after that, we are told that and the sum of the second and third term is minus 6. So I'm told that the sum of the second term and the third term is minus 6. So what do I do? The second term is AR, obviously. If you use this, when you use Tn, ARn minus 1. So to find T2, that will be AR2 minus 1. That's AR, that's second term. To find the third term, it will be AR3 minus 1, and that's AR squared. So I have AR plus AR squared is equal to minus 6. That is equation 2. Now I am going to solve these two simultaneously, but whenever you have a GP, especially in this form, and you want to solve, just divide equation 2, divide equation 1. At the left hand side of equation 2, I have AR plus AR square divided by A plus AR. The one I have at equation 1 is equal to equation 2, that's minus 6 divided by 3. If you look at equation 1, the numerator, AR is common, so factorize AR at the numerator. AR is common, so you'll be left with 1 plus R all over. Factorize A at the denominator because that's what is common. You'll be left with 1 plus R, and this will be equal to minus 6 divided by 3 will give me negative 2, obviously. So now you will see that 1 plus R cancel 1 plus R, A cancel A. So that means here I will just be left with R. So at the end of the day, to be equal to negative 2. So to get A, that is not a problem. From 1, what do I have? I have A plus AR to be equal to 3. So I've gotten R to be negative 2, so that I have A plus A times minus 2 is equal to 3. So A minus 2A is equal to 3. A minus 2A will give me minus A equal to 3. Either you bring this to the other side and bring this, or multiply both sides by minus. A will be giving me minus 3, so that at the end of the day, therefore, A is negative 3 and R is equal to negative 2. That is the answer to this question. Let's move to the next question. So we have in this question, how many terms of this series are needed to make a total of 1 over 2, 1 minus 3 raised to power 8? How many terms of this series? 2 minus 6 plus 18 minus 54, and on like that. The first thing you need to notice is that this is a GP. Now, the first term is 2, the second term is minus 6, the third term is 18, the fourth term is minus 54. So, how many terms of this series are needed to make a total of 1 over 2, 1 minus 3 raised to power 8? Now, you first look for the common difference, that is T2 divided by T1. T2 divided by T1, that is negative 6 divided by 2. The answer will give me negative 3. So, don't forget it is summation. R is less than 1. It's less than 1, obviously, because negative 3 is less than 1. So, I'm going to use some, don't use nth term here. If it is nth term, this is how they will write this. This is how they will write the question. They will write 2 comma minus 6, 18, minus 54, and on like that. This just indicates that this is a sequence. They are not adding. But once you have 2 minus 6 plus 18, they are adding it. It's a series. You use the summation formula. So I have xn, that's for a GP, is equal to A open bracket 1 minus R raised to power n all over 1 minus R. That is the formula I'm going to use. And they say how many terms. We are looking for n. And we have all other things given. So Sn itself, we know what Sn is. So I have Sn to be equal to A. A is 2. I have 2 open bracket 1 minus, we don't know what r is, minus 3, minus 3 raised to power n, that's what I have, all over 1 minus r, so all over 1 minus r is minus 3, so multiply by minus 3. Sn, the summation is 1 over 2 1 minus 3 raised to power 8, so that at the end of the day this is 1 over 2 1 minus 3 raised to power 8 is equal to, this is 2 open bracket 1 minus 3 raised to power n all over 1 minus times minus will give me plus, 1 plus 3 will give me 4, so that is what I have. So I have 1 over 2 1 minus 3 raised to power 8 to be equal to 2 divided by 4, 2 divided by 4, 2 here 1, 2 here 2, that's what I'm going to have there. At the end of the day I will have 1 over 2, then 1 minus negative 3 raised to power n. So cross multiply or multiply both sides by 2. Multiply both sides by 2. So if you multiply this by 2, you will just be left with 1 minus 3 raised to power 8, because the 2 you have used to multiply with have cancelled this 1 over 2. The same thing happens to the right hand side. I have 1 minus 3 raised to power 8. I will transfer this one to the left hand side, then transfer the rest to the right hand side. Minus 3 raised to power n to be equal to, 1 is here already, 1. This 1 will come to the other side, becomes minus 1, then plus 3 raised to power 8. So I have minus 3 raised to power n is equal to 1 minus 1 is 0, then equal 3 raised to power 8. Now, minus 3 raised to power n will be equal to, this 3 raised to power 8 is also minus 3 raised to power 8. Since the power is even, if I add minus there, it doesn't change anything, because minus 1 raised to power any even number will give me 1. So if you look at this one, it follows that n is equal to 8, because they have the same base, so the power have to be equal to each other. So this question first says find the sum of the odd numbers between 100 and 200. Find the sum of the odd numbers between 100 and 200. Now that means you want to find 101 plus 103 plus 105 till you get to 199. That is the summation of all the odd numbers as required from the question. So in reality, you need to get some things. This is an AP, obviously, with a first term of 101, and the common difference, that's T2 minus T1, obviously is 2. 103 minus 101, the answer is 2. So we need to get the number of terms. Tn equal a plus n minus 1d. So the last term is 199 is equal to a is 101 plus n minus 1 times 2. Bring this 101 to the other side, you have 199 minus 101 is equal to n minus 1 multiplied by 2. So 199 minus 101 will give me 98. Open the bracket here, you have 2n minus 2. Bring the 2 to the other side, you have 98 plus 2 is equal to 2n. 98 plus 2 will give me 100 is equal to 2n. Then divide both side by 2, the answer is 50. So that means the number of term is 50. Obviously, the numbers between 100 and 200 are 100 in numbers, and we have equal, even, and equal odd numbers. So if you actually divide 100 by 2, you will get 50. So we have 50 even numbers and 50 odd numbers. So now let's look for its summation. They want us to find the sum. Since I've gotten what I need, I'm using sequence here. So Sn will be equal to, since I know what the first term and the last term is, this is n over 2 open bracket 2a plus n minus 1d. You can use this, you will get your answer. At the same time, you can use this as well, n over 2a plus l. This is also another summation formula for the nth term, nth summation of an AP. So this is what I'm going to use. Sn is equal to, I want to, n is 50, that's 50 over 2. The first term is 101 plus the last term 199. So the sum of the first 50 terms, 50 divided by 2 will give me 25. 101 plus 199 will give me 300. So 25 divided by multiplied by 300 will give me 7,500. So the sum of all the odd numbers between 100 and 200, the answer is 7500. A man starts saving on the 1st of April. He saves 1p. He saves 1p first day, 2p the second day. The p is a unit actually. £4 the third day and so on, doubling the amount every day. If he manage to keep up saving under this system until the end of the month, how much would he have saved? Give your answer in pounds correct to 3 significant figures. So in reality, this is just a geometric progression question. A man starts saving on the 1st of April. Save one. The first one is save 1p. And it's summing up. When you are saving, it's summing up. The second day, 2p. The third day, 4p. And it goes on like that till the end of April. And April has 30 days. So in reality, you have this is 1p. That is the first term. Obviously, this is a GP. You do T2 divided by T1. That is 2p divided by 1p. The answer is 2. So the common ratio is 2. And we want to find the sum of the first 30 term. N is 30 because April has 30 days. R is 2 is greater than 1, so we use Sn to be equal to A open bracket R raised to power n minus 1 all over R minus 1. That is what we are going to use to find this the amount it saves at the end of the month. So S30, that is the sum of the first 30 terms. A is 1 open bracket R raised to power n, that is 2 raised to power 30 minus 1 all over R minus 1 all over 2 minus 1. I have RS30 to be equal to 1 open bracket 2 raised to power 30 minus 1 all over 2 minus 1 will give me 1. So in reality, this is 2 raised to power 30 minus 1. And that will be the answer, but then don't forget, because of the fact that we have to correct our answer to 3 significant figures, we have to look for what 2 raised to power 30 is. So you have to press your calculator here. 2 raised to power 30, the answer will be 2 raised to power 30, the answer will be 1073741824. Then minus 1, the answer will be 1073741823. So this is the answer in pounds. So this to 3 significant figure, that means that this is 1, 2, 3. 3 round off to 0. So I have 107. Assuming it round off to 1, it would have become 108. But 3 round off to 0, I have 107. Then the rest will be 0, 0, 0.00000p to three significant figure.